Hello, I want to introduce you a kit about scalar waves from Professor Konstantin Meyl. This is a description, the book. It's a kit which you can get from Konstantin Meyl with two boards. Altogether it's 4 boards. It looks like that. There is a Tesla coil on top with this ball in here, which can be plugged in that place, and from the back side there is the primary coil. There is a functional generator in here with up to 8 megahertz, and this is connected to this coil, and by induction it will go to the upper coil in here, and there are some electronics in here, some diodes to make this AC to DC for measurement, some LEDs, a condensator, and a resistor of 100 ohms. That's all. There's nothing more, and here are the connections for the cable from the backside again, so it's not really very exciting, this board. And here you see a fine coil with more windings, like this one. This one have half of the windings they do have, and there is 2 of these fine boards and 2 of these coarse boards. And normally this A, it's called A boards working together, and the C boards working together and not mixed. So I want to show you the electronic of this board. Is not very exciting. Here we get this high frequency signal to the coil from below, and there's the upper coil with this antenna, but it's a scalar wave antenna, a different antenna like the electromagnetic wave. And then there is a receiver, the transmitter and the receiver. They're exactly the same. We have these 4 diodes to make DC, these LEDs, 100 ohm resistor on both sides. So 100% exactly the same construction, very simple. No electronic, nothing. So on this frequency generator, I fix now a frequency, let's say 3.9 megahertz. When I turn it around, I see these lights on the receiver. It's getting less power or more power. So that means this is our first try. We see that from the transmitter, energy is transmitted to the receiver. We have a cable here, that's an earth cable, but the rest of the energy is going through the air. You have only one cable, so it's not possible that the energy is going from here to here without going through the air. And this frequency, which is a lower frequency, it's most probably electromagnetic wave. It's electromagnetic wave. And they have a little bit different characteristics like the scalar waves, which we will see later on. And the electromagnetic wave, I move now this board a little bit outside, more far away. Yeah, it's a little bit, should be a little bit less. Moment. Okay, now in this frequency it's supposed to be more, the electromagnetic wave is active at this moment. We see the lights on the receiver. That means energy is transferred from this ball to the other ball. Anyway, if I put my hand around, we see it's possible to reduce the radiation on the receiver. I'm also influencing this system by, I don't know why, but it's the fact. So if I go a little bit outside with this one, from here, there should be, yeah, we see it's a little bit less brightness, a little bit, but the effect is not that much. It's not that much. If I go very close, maybe you can see. Now we can see that it's going more, the light is more bright. It will be more light. We go more close. Okay, at least in this area it's visible. Now there is more power. If I go outside, there is less power. Okay, more power when I'm more close. If I go outside, the power of the LED is less. Now if you look at these two lamps in here, the brightness, if I switch off the receiver, like I'm doing now, it has few effect on this LED, very few effect. They're almost the same brightness. I put it back again. Okay, we see a little bit, it's going a little bit down, but not very much, not very much. And now I have a box here, which is also shipped with the kit. And now we see the lights is on. I put the box around this ball. It's a Faraday cage, and we know the electromagnetic wave, when it's in the Faraday cage, the radiation is, yeah, I think you don't see the lights is on anymore. It's off because the receiver is in the Faraday cage. And we know inside it's shielded. Okay, open it again. At least if I open it a little bit, we see there's already something coming inside, but when it's completely closed, there is no power anymore on these two LEDs, as we know from our physics, because it's a box which is shielded. Okay, now we are going to the scalar wave mode. That means we are increasing the frequency on this device. There is an adjustment. Anyway, this is a amplitude, and the amplitude could be full, the maximum amplitude. The offset, that both lights are the same brightness. Otherwise, the offset is necessary here in the middle, and this is the frequency which is going up now to 5.789, and we see the light is on the receiver. Yeah, we can go more high. Now the light is off. The receiver is on. This is resonance. Now it's in resonance frequency, but we go a little bit less now to leave it on, the light on this transmitter, and make a test. Yeah, what does it mean now? It means again we have another frequency where energy is transported through the air. Yeah, there is transmission from energy from here to here, and it's leaving a little bit more energy, I would say. Yeah, if I go in here, I see the lights are more bright like they have been before during the electromagnetic waves. So there is the possibility to transmit more energy through the air by scalar waves. When I go down a little bit and move the transmitter a little bit outside, let's say 1 meter, 120, 130, 140, we see the light is almost the same. Is almost the same. Okay, this effect was not so much during the electromagnetic wave, but when I go more close, okay, the light is a little bit more when it's more close. Now the resonance changed a little bit. Yeah, it's a little bit more bright. It's correct. I go out again. Now my hands is the resonance frequency changes with the distance, so I have to readjust it. Okay, to come here again. So both are a little bit the same. Now I move it more close. So when I go here, I see the light is more. That means I'm influencing the system, but when I go retreat, then the light is a little bit less. I go more close when I retreat. It affects the resonance frequency. Okay, in this case the effect is not that high. What should be the effect? That the brightness remains the same whether I'm very close or whether I'm far away. Okay, but we see I need to readjust. This effect is not that high. It's not that much. But now when I take out the cable the earth cable from this device, I can do that. I see that the light is much more bright in here. That means the transmitter detects that there is a receiver and that he takes energy. And this is different now from the electromagnetic wave. In the case of electromagnetic wave, this was not a big effect, but now it's a big effect from this removing of the receiver to the brightness of the lamps, of the LEDs. When I put it in again, I see the brightness going down very much. So this detects whether there is a receiver on the other side or not. And it's not the case in these electromagnetic waves. Okay, now I take the box and do the same like before. That I make a Faraday case. That means I remove this radiation, if I can do it, and close it. Yeah, and I see now the light is still on. That means within the Faraday case it's going through it. It's not shielded by this case. When open again, it's not very much different. So this indicates that there's a difference in the character in the electromagnetic wave and this scalar wave at a frequency of 6 megahertz. Okay, that's it for now. Thank you. Now we are making the next test with transmission of the energy through the space, yeah, through this gap in here. Anyway, there is a resistor of 100 ohms on these boards. The same, they are identical, these two boards. And we are measuring the voltage on this resistor of 100 ohms on the boards. Okay, now the voltmeter is plugged in with voltage on the transmitter, which is 0.583 volts at the moment. The voltage at the outlet of this transmitter, 0.58 volt. Now I'm going in the receiver plus and minus, and there are 4 diodes to make DC from it, plus and minus. Wow, look here what I can see. 7.7 voltage. 7.7 volts, that's very interesting. That's way too much. It's much more than at the center. So that means we have more energy at the receiver than on the transmitter. Very interesting, very interesting. Over unity, sounds like over unity. Maybe, maybe not. Maybe I make a test. It's not over unity because this device is the frequency generator needs a lot of energy. So at the end there is no plus in energy. It is no plus. But I switch off this functional generator now, and we see it going down slowly to 0, slowly, because there is a condensator. On this board there is a condensator. It discharges its energy slowly, but that means it's coming from the frequency generator. It's not, maybe not coming from me or from somebody else. The source of the energy is the frequency generator. It's falling down. We are waiting a little bit more until it drops to 0. Very slowly. Very slowly. If you make a shortcut, then it will be faster. So we make a shortcut. How is it now? Yes, now it's millivolt. Now we discharge the condensator. Okay, we switch it on again. Resonance frequency. Now I have to readjust my frequency here to 6.1. 3.1. And we see again it's going to 7.4 volts, which is really interesting. We make the double check. We go back to the sender, to the transmitter, checking the voltage, plus minus. And we see it's 0.9 voltage. That's interesting. That's quite interesting. And we are moving the receiver now. We can see our 7.4 volt. We are moving it more away from this point. still remains on 7.3 volt. 7.5. A little bit more. The cable is not so long. So maybe that's the maximum. We see there is no change in the voltage. Oh, it's a little bit now, 6.5. Around 7 volts, 6.6. Maybe it's a little bit less now. Let's go now the opposite direction, very close to the transmitter. 5.3, it's even a little bit less. That's interesting. That's interesting. Yeah. The more close I'm coming to the transmitter, the less energy I do have in here. Maybe if I readjust the frequency, it can be that it's changing a little bit. 5.4, 5.2, no, it's going down. But that's somehow a little bit interesting. When I go about 50 centimeter, I have 6 volt, 6.9. Let's say a little bit unstable. And also when I'm touching it, I influence the system. 5.0 now. How it was when I go more close. 5 now. It looks like there's maximum and minimum. I go a little bit more to here. 5.1. A little bit more close. Let's say very close. 4.3. Okay, that is at least significantly lower than it will be when it's more far away. So it's interesting, very interesting. You can make your interpretation about that. But the most important thing is that there is more energy harvest in the receiver than it is on the transmitter. That's the most exciting thing. And I switch it off again to show that it's coming from this frequency generator. You see the voltage is going down. You want to speed up? Yes, it's a little bit boring. You make a shortcut. Okay, let me check again. Now it's millivolt, 200, 0.6 volt at the moment. Yeah, I think that's quite interesting. You can make your interpretation. The next one I cannot show you. I would like to, and this is the transportation of medicine by these systems. In this book there is in the laboratory they have 3 balls and they put a sample of cancer cells on one of this one and on another one. On 2 of these boards they put cancer cells. I don't think that you see it from here. No, there is somewhere, there is how they put it. And then they make 1% natrium acid kill the cancer cells on one of these, let's say, in this case it's a receiver. It was a receiver. For 9 minutes. After 12 hours, all the cancer cells in the other glass died completely. That's very interesting. That's very interesting. It's true or it's not true. That's up to you to prove it, to check it. But that means that there is also information. It's not only energy. We can see the energy in here. It's very easy to see it. But also biological information is transmitted by this system. And that's really amazing. But slowly there need to be more tests about that. But if it's true, that means biological information is transferred also by this system. Yeah, and it maybe can use for medical purpose. Maybe. But it needs time. But at least it's interesting to do more investigation. And that's what I want to motivate you. Thank you very much. Okay, I want to show you one more interesting effect where I cannot explain why this effect takes place, but it's very interesting. This frequency generator is powered by 5 volt power supply. So the input is 5 volt and the output of the frequency is 9 volt SS, 9 volt SS. Yeah, the maximum amplitude of this device is 9 volt. Yeah, now we are below that. We are at 5.3 volt. So it's not more than the source. Yeah, I'm going down now with the frequency, and we check the voltage. Okay, now at 6.1, this is a resonance of this, let's say, the scalar wave, and I'm going down now more close to the electromagnetic wave. Yeah, we see the voltage is going down. We are out of resonance. Less energy is transferred through the air, through this system. 2.6, 2.5, we are 5.0 megahertz, 4.7. Now take a look carefully. Yeah, 4.7, 7.9, 15, 18 volt. And what is this? It's more than the generator. It's more than a generator. 18, 29 volt. What is going on? To be honest, I have no idea. I have no idea. That's up to you to give an explanation for that. I'm going down. This is 4.2 megahertz, and this is more the maximum of the electromagnetic wave now. 20.8 volt. I'm going down more, and then we see maybe it collapses again. 24, 20, 19, 18, 17, 16. Now it's going down again. So there is a power maximum at the maximum of the electromagnetic wave on 4.1 megahertz. That's brilliant, that's amazing, but I have no explanation for that. I have no explanation. Now it's going down 4 point. Yeah, more and more down. I'm 2.9 megahertz now, but at least let's go back again that we can see, we can verify it on 4.0, 4.1, 12.5, 28 volts. Wow, 28 volts. But it's coming from this device. Let's check it. I switch it off. The device, the voltage is going down. The voltage is going down. Do you remember? This is 9 volt maximum peak. 9 volt peak. And it's much more voltage on this one than from this device is coming. So this is a question. Maybe you find an answer. I don't find an answer right now. Okay. Thank you. Okay, we are doing one more testing. It's interesting, it's amazing, yeah, to do this. We are not in resonance now. We are a little bit below resonance, 5.6 megahertz, yeah. And now we have the lumen. We can measure the lumen. That means the light, which is 74 lumen now. Yeah, 74. Maybe you can see it here, 74. And now I'm going from 50 centimeter to more than 1 meter. Let's say the maximum is 1 meter. The cable 1 meter 50. No, 140. 140. And I put this device again in here. So we can see it's 64 lumen. Yeah, this is almost the same. When I go from 50 centimeter to more than the double, there is no change, not very much change in the intensity. Yeah, that means contrary to the electromagnetic waves, which the intensity will go down, we see here it's constant. It's constant. That's interesting, but it's not completely correct, because if I go very close, we see now, also from our eyes, that there is a change in the brightness, going to 360. So if you are very close, in a very close distance, the intensity of the LEDs is going up a lot. And only this effect that there is no change will happen from 50 centimeter, where we go back to, let's say, 100 meter and 40. We go back in here, now we have 43 lumen, and the transmitter lights change again. We've seen if they come very close, they go down. The lights go down. You remember? Okay, let's do it again. Yeah, the lights are off. And we have a high energy is transferred now to the receiver. Okay, let's go back to 50 centimeter. And here we have again our 45 53 lumen. Okay, let's go now to electromagnetic wave, which is more down. Maybe remember it was 3 point something, that we have a transmission of energy in the electromagnetic. Sometimes not so easy to find it. Okay, here we are. Here we are. Now we are at 3.7 megahertz. This is more, let's say, the electromagnetic characteristics with 50 lumen. We have 50 lumen now. And now we go do the same. When we go out to 1 meter and what was it? 40? 140. And we measure as well. We have what? 41. Now let's be fair, move it more close. Oh yes, 25. 25. No, it's 48. It's 48. So also for the electromagnetic wave, as far as I can see, it's the same. I would like that it's less, but it's not the case. I can measure the same intensity of the light. Yeah. And then we go very close as well with the electromagnetic wave. And now it's a little bit different. The sender is still very bright, and the receiver, it's 116 lumen, so it's a little bit more like it will be in 15 centimeter. Yeah, but we take a look on the lights on the transmitter. If we move it outside, they don't care about this. They don't care about it. So the transmitter is now 680 lumen in here, 680. He doesn't care what is going on the other side. Whether the receiver is close or far away, it doesn't care about that. But does it care when I take out the cable? Can we check it? Take out the cable. And the lumen is 760. Yeah. Almost no change. I put it again, the light, 600, 700. So it's a little bit a change of the lumen on the transmitter. If I remove the center, the receiver. If I remove the receiver. One more, and then we finish. We go back to 6 point blah 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 megahertz for the scalar waves. Now our like this, and now I'm removing the receiver. Okay, it's going a little bit more up. It's 370 lumen. Okay, here we have some effect whether the receiver is connected or not connected. Now we have 50 lumen. Okay, and when I remove it, it's going to 250 lumen. So the transmitter realizes that there is a receiver taking the energy. Okay, that's it. Thank you very much.